Yeah, nice to see you guys. This is our third call, and it's good to see a few of you who've attended all of the calls. Obviously, you're interested in the topic. I would encourage you to share your video camera if you can. It just makes the interaction a little more interactive.
Yeah, I'm having a problem with my camera. I'm just working on that right now. Hopefully it'll be up
Okay.
soon. We don't use Zoom very much here.
Okay.
I'm
Right.
I'm not going to have my camera on due to bandwidth issues for my kids also doing Zoom meetings right now. Because
Right.
why not
Yeah.
have 3 Zoom meetings on one network, one home
I
network?
know.
See how that
I
goes.
know.
So
Yeah. Yeah. That's okay. It's just just a suggestion. I know it's challenging with a 2 hour long meeting. You don't want to be eating on a call, so you need to take a break sometime. Okay, I'm not able to share my screen mic. It says only one participant can share at a time.
Let's see.
Okay, got it. No, it's working. Sorry. It was just a notification, but it's letting me share. Okay, this is the meeting for today. Perfect. Okay, so welcome everyone. This is our third call, the third stakeholder meeting. And as you know, in the previous meetings, the first meeting that we had, we kind of introduced the topic. We told you what we would be doing. And in subsequent meetings, we've been talking about the technical aspects of this project. I do see a few new folks today. Most of us have been around for the 3 calls, but I see a couple of new folks today. So we'll just do some quick introductions for those new people, and then we can get started with our agenda. I believe, Yuan, this is your first call, right, for this project?
Ewan's with AI. He's going to be running our demo.
Oh, excellent. Perfect. Yes. Yeah. Yeah, we've interacted on Project Stasio. He won one of our competitions.
Correct.
So, yes. Yeah. And Chris Ballback, is this your first call as well on this project?
No, I was on the kickoff call. I missed the last call though.
Okay. Okay. Perfect. Yeah. Welcome back, Chris. And there's nobody else, right, who's calling in for the first time? Phil Roy, I forget if this is the first time you've joined this call.
No, I was on the kickoff meeting as well. Yeah,
okay.
I couldn't make the last meeting, but yeah.
Perfect. Okay. So for the few of you who missed the last meeting, just a quick recap. The meeting minutes are on the Google shared folder, and Mike Wilson had shared them with us previously. We, at the last call, we had 2 tool demos. Patrick demoed Cove tool and Andrew Conley demoed Sapphira. Like, just to remind you, the intent with these demos is to kind of get an understanding of how simplified modeling tools actually simplify the modeling process. And that has been guiding us pretty significantly throughout with the development of the rule set. We spoke a little bit more about the applicability criteria. So we're trying to limit this simplified performance approach to simple buildings. And through the 2 calls that we've had, we decided that that criteria should not be determined by the size of the building or the number of floors, but it should be more based on the features, the systems and use types of the building. So in terms of use types, we are limiting this to use types like office, retail, apartments, and we would not have any use type which has complicated ventilation requirements or internal loads would not qualify to be evaluated through this approach. And then in terms of systems, we are limiting this to buildings with simple systems. So any multi-zone system or any kind of heat recovery, dehumidification, humidification systems would not be evaluated using this approach. The other thing we looked at during our last call were use case applications. So where does s-PRM apply? Who would be using it? And we said this would be applicable for new buildings, new construction, and existing buildings for both code compliance and for beyond code performance or utility incentive programs. So whenever you're required to do modeling, your building is eligible for evaluation through the s-PRM approach. This can be used for compliance or for any beyond code program. In terms of who would be using it, we did not want to call them modelers or architects, and we thought the term an educated user would be more appropriate. So someone who, because this will be a simplified modeling approach, we're not looking at extensive energy modeling expertise, but just a knowledge of building systems, of simulation tools, of requirements, of code requirements, etc., would be what would be an educated user who would qualify to use for this, or implement the rule set. So those were some of the things we spoke about last time. And we started getting into some more details about the simplified approach. We briefly spoke about requirements for a simulation tool. So just to jog your memory, we said the requirements for simulation tools would be pretty much what Appendix G has. So an engine which has been tested with standard 140, ability to evaluate thermal mass, economizer, things like that. But we added 2 additional requirements. One would be that the baseline is, it's required that the simulation tool can automatically generate the baseline. So the entire idea behind this approach is to make energy modeling more streamlined, simple, less time consuming, and having an automatic baseline is one way of doing that. So that would be one criteria. The other criteria was all aspects of the building that are being evaluated need to be supported by the simulation tool. So like Appendix G allows for the use of exceptional calculation methods, that would not be something that s-PRM would allow. And all the features that you want to evaluate should be a capability in the simulation tool. Then the other thing we spoke about was building use types. So basically the space type categorization. So like Appendix G 90.1, it allows the use of building area method and the space by space method for defining an energy model. Now the space by space method just inherently kind of more introduces more complications in the energy model. So you end up defining spaces to the level of detail that they are present in, and then you end up defining internal loads to that level of detail. And one approach for simplifying the modeling process was to not allow the use of this space by space definition and use building area types as defined by the section 9, which is a lighting section in 90.1. And so far, all the simulation tools we have looked at, the simplified modeling tools, they also have this capability for a user to just select the building type, and it provides a list of default values for internal loads that then a user can modify. So just building on that feature that we've observed in simulation tools, we can limit the simplified rule set to building area types and not use the space by space method. That was everything that we discussed last time. Does anyone have any questions, or do you want to add anything to this quick recap? Okay, then we can move forward. Thanks, Patrick. Yeah, you can tell I've been listening to the recording. I listened to the recording at least 2 or 3 times, so I remember everything. And it would be amazing. It's like pretty amazing how annoying your own voice sounds on recordings. So, but yeah. Okay, so for today's call, we'll talk about some of these simplified approaches which we didn't get into at the last call. Building geometry, lighting, and if we have time, we'll also get into HVAC systems. Then we'll have some discussion. We'll have discussions throughout, but yeah, we've just set aside some time to talk about all of these specifics. We only have one tool demo, and Fred and Yuan will be showing us the simplified modeling tool that AEI has developed. And then towards the end, we'll have some discussions. We can all ask Fred some questions about the tool, and in general, if there's anything else we want to touch base on. Okay. So we've had 2 stakeholder meetings so far. So just to let you know how our meetings are going to progress. We've had 2 meetings so far. This is our 3rd meeting. We think there would be 1 more meeting in December, by which time we want to have the draft rule set ready. We'll walk through the specifics of the draft rule set during that call, and we're also looking for people who can review. So just an external peer review of the rule set. So towards the end of today's call, we'll just see if there are folks who would like to be involved in that. And so like similar to Appendix 3, so we basically, the way we're writing this, we're incorporating the s-PRM rule set within Appendix 3. So it would be evaluating like the technical aspects of things we would have already discussed by that time, but also the way a user reads this rule set, the different compliance parts, and whether it's clear on when the s-PRM approach applies. Those are the kind of things also that we would be looking for feedback on. In terms of future meetings, we're not sure if we're going to need meetings in the future. This project's going to go on for 2 more years. Next year, we'll be looking at validating the s-PRM approach and also developing the simplified building performance factors. And the 3rd year, we would be running a pilot. So if we do need meetings at that point of time, we'll figure that out and probably reach out to all of you again. But so far, we don't have anything on the agenda for future meetings. So I checked the applicability criteria yesterday. Now, based on the feedback we received at the last stakeholder meeting, we had excluded buildings with data centers, kitchens, and locker rooms. And all of you mentioned that most buildings have small IT closets or small pantries which do not require extensive exhaust or ventilation. And there are small locker rooms with a 1-person or 2-person shower. So we should not exclude buildings with those capabilities or those features, and probably have limits on such spaces, but allow buildings with those spaces or systems. So we've updated the applicability criteria based on that feedback. There was also some feedback, I believe, Fred, from you, to include district heating and cooling systems. We were previously excluding buildings with district heating and cooling systems from the s-PRM approach. We haven't yet decided on what to do about that. Mike Lou is working with the ECB subcommittee to modify rules for district heating and cooling in Appendix G. So we're waiting to see. Yeah, Mike, go ahead.
So it's just to be clarify what I was thinking there. It's when it's purchased steam or heat or chilled water, not the upstream central plant equipment. Literally just when it's just a BTU meter and you're not taking credit or accounting for the district system itself. Because then technically that's the simplest HVAC system that exists.
Right. No, you're right. I should call this purchased hot water, purchased chilled water. And Mike, can you just give us a brief overview of what ECB is looking to change with purchased water?
Okay. Can you hear me, Supriya?
Yeah, we can.
Okay. So the change that we're looking to make is to essentially remove the requirement that purchased heating would get modeled in the baseline, and instead create adjustment factors for the proposed design model that would basically be like a site to source efficiency, but it would be focused on trying to keep energy neutral the efficiency gains that are included in the BPF factors. It would be an adjustment to just sort of neutralize those, so that a building using purchased heating or cooling wouldn't have a penalty or a benefit relative to baseline. So it's in progress, and unfortunately I can't share too many details because that's sort of the ASHRAE policy, but we think we've got a method that eliminates the current problem with purchased heating and cooling and the building performance factors and the way they're calculated that should be agreeable to the folks on the 90.1 committee. So
Yeah, that makes sense. So I guess once that process is in place, then that's something we could adopt for s-PRM as well. That makes a lot of sense, just using factors similar to site to source conversion ratios for evaluating purchased hot water and purchased
yeah,
cold water.
the trick is going to be coming up with the right values that are sort of match the credits that you get, or the savings that's sort of embedded within the building performance factors for heating and cooling equipment. So they would really be adjustments to sort of offset those improvements in efficiency that occur between the baseline and whatever the current version of standard 90.1 is.
Right. Okay. Thanks, Mike. The other criteria we had discussed was excluding multi-zone systems. There was some discussion we had on whether that's too restrictive. But like we said during the last call, we want to keep this really easy, at least for the initial first round. And multi-zone systems come with their own complexities of controls, ventilation, etc. So we currently are still planning to exclude multi-zone systems from s-PRM. Gail mentioned looking at additional use types like community centers, libraries, because they're really simple buildings. Again, right now I'm a little unclear on what that means for s-PRM, because like 90.1 Appendix G has building performance factors. So, and community centers and libraries are probably, and Mike Rosenberg, maybe you can provide some more guidance on this, but I'm assuming those two use types map to some of the existing buildings, some of those existing use types in the building performance factor table. And can we use the same approach then to allow for community centers and libraries?
I mean, I haven't really thought about this, but I would think that those two building types, libraries and community centers, would fall under other, you know, something
Right.
the category not covered.
Right. Okay. So we will think about, and Gail is not on the call today, I think, otherwise I would have confirmed if that's what they see.
I am on the
Gail.
call. My apologies.
Oh, great.
I'm not able to use Zoom, so not able to see anything today.
So no worries, Gail. Oh, you can't see the slides either. Okay, let me see if I can send them to you. That way, at least you can follow along. So Gail,
Perfect.
just, yeah, quickly, what do you think about, how do you see these lead submittals? Are they typically, do these use types get mapped to other building performance factors?
Yeah, frankly, we have not seen much with building performance factors yet. You know, we're still very limited in terms of the 90.1 2016 projects that we've seen, and most of those have been residential multifamily. But you know, I think they could be, depending on the types of uses, they could match schools to a certain extent, or they could match, you know, some of the other use types in terms of building performance factors.
Right. Got it. Okay. Okay, that makes sense. So yeah, we'll figure that out, Gilly, though we'll explicitly state that because we weren't thinking of having an other category. So we'll either explicitly state where these use types would map to, or we'll include an other category which can cover this. Okay, my screen share stopped working, so just a second, I'll try that again. Sorry about that. Okay, perfect. So any other thoughts or anything that folks want to discuss about the applicability criteria? Great. Then we'll move on to the scope of the rule set. So at the last call, we discussed the space use classification, schedules and loads. On schedules and loads, just to jog everyone's memory, we were initially proposing using default values for schedules and loads based on 90.1 Appendix C. And there was a recommendation by the group to use defaults, but if someone overrides the default, then require them to submit some kind of justification. So basically allow a user to override it with supported documentation. That makes sense. So we'll see if that's something we include in the rule set. But in general, the group felt that having default values for schedules and loads would be a good simplification. So for today, we'll talk about geometry, envelope, lighting, and if we still have time left, then we'll get into HVAC system. In each case, now we're talking about simplifications for the proposed building. And obviously, in these cases, the baseline is supposed to be the same as the proposed. So the simplifications translate over to the baseline building as well. Geometry and thermal zoning, that's a very big aspect of energy modeling, which most people spend most of their time on. And this is what leads to most of the biggest complexities we see in energy models as well. So of all the simulation, of all the simplified modeling tools we've looked at so far as a group, and also that PNNL has evaluated outside of the demos, we've seen several ways for simplifying building geometry and also the thermal zone layout. Just looking at geometry right now, the simplest approach we've seen so far is simulation tools just assume a rectangular geometry by default, and then just adjust the width and the height, the width and the depth, length and the depth based on the flow plate area, and either a user input for an aspect ratio or a default assumption for an aspect ratio. So they would typically they would have inputs for the conditioned floor area, the floor to floor height, number of floors. Through that, they'll just calculate a flow plate size, a flow plate area, and using the default aspect ratio or user specified aspect ratio, convert that to a rectangular building. And these would then have typically perimeter and core thermal zone layouts. So this is the simplest approach we've seen in simulation tools. Another approach is a multiple block approach where tools offer predefined shapes like T, H, U, L-shaped blocks, and a user can specify dimensions for these blocks and use one or more of these to create a geometric representation for their building. This is the approach that Assets Code tool uses. Another approach, and also the TSPR tool, which is being used for Washington State for code compliance. Another approach is a simplified flow-by-flow geometry. In this, a user can either import a GBXML file and then trace over it, or import a 2D floor plan, trace over it, and create a floor-by-floor for geometric representation for their building. And in this case also, they could have a custom zone option, or in most, what we have noticed is more like a perimeter and core zoning layout. And another, the most detailed approach is method 4, where a user can create completely customized geometry and customized thermal zone layout. There are no restrictions for any level of simplification. So we were initially contemplating requiring one of these approaches, but we think that's a little too restrictive. And another easier approach and a better approach for this might be to just have some acceptable variations for all geometric aspects of a building. So the fact that we use building area types and not space by space, not the space by space method, a user is not going to create, hopefully not going to create custom geometry to the extent where they're creating corridors or different spaces explicitly. So through a building area type, there is a way to simplify your building geometry as it correlates to spaces or functions in a building. So by having some acceptable variation for opaque surface area, fenestration surface area, and building volume or just conditioned floor area, a user could simplify the geometry further and not create different surfaces for every niche in a building. And similarly, so the rule set could instead specify what this acceptable variation is, and a user could use any of those 4 methods to create their building geometry. So a couple of questions come up with this approach. Firstly, do folks think this can result in simplifications? Is this a good approach to encourage people to simplify the building geometry? And then if yes, what would your thoughts on that acceptable percentage variation be?
I have some thoughts.
Yeah, go ahead,
Thanks, Freya.
Okay.
I got a few things. I haven't said this yet, but I'll just start off saying again, I think it's good to know what you want the standard to really assess. And I think it's probably, if you know sort of the types of scenarios or use cases for the standard, then I think it can become easier to answer this question. But I'll try and answer the question without that anyway. I think one of the things that we have observed I was quite shocked actually, is how many people don't understand how perimeter zoning versus single zone per floor really affects an energy model. And I would be sort of strongly encouraging you to try to nudge people to have some sort of zoning, you know, even if it's perimeter core, because unless you're you're not really that interested in assessing the facade, as soon as you get to the point where you want to assess how well the facade affects energy use, then you really can't do that without proper perimeter zoning of a model.
Right.
At least of a model of a certain size, you know, of a building of a particular size.
Yeah.
So that would be sorry, just one other comment as well. I was just going to say on the last slide as well, and I think, you know, you've got the right approach here by looking at this, but on the previous slide, the method 4 actually has loads of simplifications that could be applied. Like there are many different levels. So one of the things that we had always struggled with in as a vendor trying to solve that problem is loads of edge cases, which when added on top of each other create quite a lot of geometry that you can't support. And in particular, I'm thinking of split levels, atriums, double height spaces, you know, atriums or double height spaces, pitched roofs, there actually are a lot of edge cases in that thing that you could try to simplify in some way, or not.
Right.
And I guess with the other three options, or with anything that's not coming out of a BIM model, I think you're kind of swimming against the tide a little bit, because
Right.
you know, there are lots of codes and standards. I'm sorry, I'm monologuing a little bit here, Supriya.
No,
there are a lot of codes and standards that that sort of take one of those first three approaches, and they're all essentially predicated on they drive the workflow into a specialist workflow. Then you're not going to get architects doing those first three workflows. You're only going to get an architect engaging with the product if you have a workflow that lets them use a BIM model or a visualization model. And you get many complaints about how painful these kind of things are. I'm thinking of there's just a lot of different there are a lot of different compliance tools that essentially use spreadsheets or other tools to try and get people to manually enter data, and they can even be quite hard to extract from a BIM model.
Right.
So you know, I just wanted to add that. It doesn't mean you shouldn't do it that way, but I think that you might find that if it was pushing people down that path, you could potentially be you know, you could potentially be creating a specialist product unwittingly, even if it's not the same sorts of people that are in this particular, you know, group. So there's some thoughts anyway. Like I think on the main question that you had, I think addressing perimeter zoning is a really I think it's a really important issue if you care about assessing how the facade is really impacting energy use.
Andrew, I was just gonna throw out there, like, have you guys actually tested the perimeter core versus single zone modeling? Because I know, like, you know, according to like a lot of the research out of Georgia Tech and things like that, that there's really not that much of a difference between those.
Yeah,
if
I was
you're looking
wondering
at
the same
early
thing.
models. And certainly, like Yuan, who's also on the call, is also kind of comes out of that research background as well. I mean, we've tested the PNL prototype models on like every single climate zone to test those things out. So and using Energy Plus, it might be something that wouldn't be too much of a thing to overcome.
I think we're losing sight of what the intent is here. Ultimately, the intent is to design a building and answer questions, and doing it quickly and efficiently when you're at the early stage of a project. And so, whether overall energy results aside, if you merge the core spaces into the perimeters, you're going to get your loads will be meaningless to help assist design, and the architects will want to hear about specific impacts to the overall building, on a facade by facade basis, or a room by kind of a typical room. So you had a bank of offices on one facade. What does it do to all those? So whether it has a huge, the merging of it has a huge result on the overall EY is kind of a secondary question. Is really, can you answer the design assistance questions effectively? And then I don't think you can. We do not. In the simplified workflow, we'll show you. We still separate out core from perimeter. When we do some other simplifications, you'll see that, but to be able to clearly answer a question that an architect might have, you don't want to lose the granularity if you can avoid it.
I can answer the first question as well. I mean, we have a simplified mode in Sapphira. So we have a plugin. I think for those of you who saw the demo, we have the plugin that just tries to get people to a result as quickly as possible, and that's a single zone per floor model. And then people can export that model into the web application, which does a perimeter core zoning, and that's the #1 source of support tickets and complaints about the product is the fact that the two results don't match. And it's not that they just don't match, but they're often really quite different. And the main reason they're different is the zoning. And so like, so, you know, it's just, and Fred's comment is like, Fred's comment is bang on as well, in that most of the people that are using our product are trying to sort of like justify or assess different facade strategies. And in a single zone model, it's actually really quite hard to do properly. You can do it, but it's much more effective if you do it in a perimeter core model.
Right. Your interior loads will dilute the impact
exactly
of the facade.
Exactly.
So.
Yeah.
I would just add to that. I'm aware, like Patrick, what you mentioned about the EPC study, like comparing the modeling the perimeter zone or combining the internal zone with perimeter zone. From a recent study we conducted here in EI, with like a recent publication on the BPAC, what they found out is really the difference. What really make a difference is the space types. So usually the internal zone and perimeter zone are different space types. That contributes to the discrepancy introduced by applying this model reduction measure, so-called model reduction measure, by combining the perimeter and internal zones. So really, I guess what I'm trying to make here is the space type plays a bigger role when trying to decide whether to combine the internal zone and perimeter zones.
And to build on what Yuan said there, if you wanted to say you had a core of any building, and with multiple different space types in it, in order to get that core to be neutral between the single floor and then one big zone and smaller zones, you'd actually have to aggregate them. You'd have to put in, you could do it with a spreadsheet, which is kind of what we'll show you. You have to aggregate the lighting power densities per square footage and the schedules per square footage, and essentially create a core space that is an agglomeration of all those two. Because if you're not doing that consistently between the floor by floor versus then the breaking it out, you're introducing another variable that can be pretty dramatically different. It could also be very small difference, but it's going to be uncontrolled as a variable. And that's really why you're seeing results. We're saying some projects said, oh, it didn't make a difference, and other projects said it made a huge difference. It will be on a case-by-case basis, and there's really no way to know which one you're going to end up with at the end. So it's a risk to the modeler.
The other thing that's
what about for system
adding
types that,
sorry.
Is that still true for systems that aren't multi-zone? I mean, we're kind of in this single zone.
Well, I was going to actually, just that point, Scott, I was going to say, if you have a single zone design and you're doing one system per zone, then it's almost even more of a difference, because you're going to, especially if those systems don't modulate very well, then now you've got zones, you've got, with a single zone per floor, you've got a fairly sort of constant load. The sun goes around the building, it comes in at one facade, but whatever, and then you've got a big internal load that's driving it. If you have perimeter zones and a core zone, and each of them has their own zone unit, then those are going to have a big fluctuation in the load versus the peak. So they'll be operating at part load a lot more, and then so how you select those systems will be critical. Maybe in the models, maybe in the buildings that you'd be looking to test with this feature, those buildings wouldn't have those sorts of systems in place, zoned up that way. And then so that throws up other questions about whether that's the right approach as well, right?
Right.
I guess just to be clear, is anybody arguing for a single zone on a given floor? I certainly am not.
I guess what I'm putting forward is that there is, if your goal is to do a simplified modeling approach and you want to make it so that the maximum number of models could be evaluated, we all know that most buildings don't have closed geometry very often. So it is like if you're importing stuff from Revit, for instance, or any other 3D modeling application, it's usually you can accept the maximum number of 3D models when you don't require them to be into perimeter core or some kind of zoning. Obviously, you do get an increased level of accuracy when you do go to perimeter core, but in our studies, we've seen that if the purpose is to kind of get the 90-10 rule of getting most of the way there, you're probably going to see like about a 1 to 4% difference depending on the percentage of glazing, depending on what, that's like the maximum deviation from a perimeter core versus single zone. So that's a thing that I've seen. And I certainly would encourage anybody who can run a few hundred models and want to try it out. It does work, but I would say like in terms of if we're thinking about this for reduced order modeling, which is kind of like the point of doing kind of this type of thing, that might be a consideration to do that. However, of course, if you're going to do a detailed model, perimeter core is definitely better, especially if you're looking at an hourly or monthly breakdown for something like that.
I guess one other thing to keep in mind is when is this happening? Mm-hmm. You're talking about importing geometry. We do a lot of energy models in the absence of geometry. Mm-hmm. We have a building program and a location, and they want to start knowing energy results and system design results. That's what happens out there these days, and they're still, adjusting building square footages and so on. So, and again, I know this is for a compliance rule set, right. But the intent, which means is again at the end of the building, and you have detailed geometry available to you. But I think also that if you want to have the process be available to inform the design and get you a better performing building, then it needs to be available right from the start.
Right.
And this scale, what we have observed from a lead perspective, I think this will be a little bit less under 90.1 2016, is the changes in system types between the baseline and proposed can have a very substantial effect based on a difference in zoning, and particularly because of the 90.1 2016 baseline rule set, and so from that perspective, appropriate perimeter core zoning, and then making sure that you do have maybe a dual core zoning to account for significantly different space types in the core would be important from the perspective of the baseline versus proposed case.
Okay. Yeah, that's helpful. So basically, from what I'm getting from the group is the geometry simplification is not as much of a concern as the thermal zoning layout simplification, and most of us feel that there should be some requirement for perimeter and core zoning, and probably even dual core zones, though we don't have multi-zone systems with reheat, but it can still have an impact on single zone systems. So did I capture that correctly? Does anyone want to add anything to this point?
Hey, Supriya, it's Dimitri.
Yeah, go ahead.
Maybe this is something you guys will be evaluating during next year's activities, but one of the things I'd be interested in, this is a question I've had in my mind, but I've never really had a chance to evaluate it very closely, is for the simplified zoning, if you just have perimeter and core zones, how important is it the actual placement of specific space types? If that conference room is here versus there, perimeter versus core, et cetera, how much variance is there when you account for that? So, for example, if you have perimeter and core zoning, pretty simple thing to create, and you just enter in this matrix of X% of space type, for this building, can you just spread it out evenly, or do you have to place it in the right spot? And if you spread it out evenly, how much variance do you get compared to that real model? So that's something I think that'd be really useful to evaluate as part of this project, if you guys could, because if you can get away with not having to, define exactly where that conference room is or where that telecom room is, then that's fantastic. That saves a ton of effort.
Yeah.
Oh,
So
no
this is Fred.
worries.
This is Fred. We can address that one because we've definitely beat that one to death at AEI.
Awesome.
Great, Fred.
Um,
You saved us a month-long effort.
Yeah. No, it's about a 4-year effort. Sorry.
Wow.
Yeah. To really to nail that down. And again, it'll be I feel like we should have done the demo first or have answered half these questions.
That's actually true. Yeah.
But anyway,
yeah.
here we are. No, so interzonal heat transfer matters if you have spaces internally that are substantially different temperature.
Correct.
And so if you have unconditioned spaces in the core, or and again a substantial scale, a mechanical shaft or something, it's an unconditioned space technically, but it's not. It's surrounded by conditioned spaces. But if you have like an unconditioned stairwell that has communication to the roof and to the ground, or you have a cold room or something, or anything along those lines where you can get substantial heat transfer between spaces, then it matters.
Right.
Fortunately, like in 99.9% of buildings, it doesn't. And many of you guys know what AEI does. We kind of work on the 1% of weird buildings. Even there, it rarely comes up.
Interesting.
And so, and then we often will just insulate those. Essentially, it's an interior partition, but it's between two rooms that are of substantially different temperatures. So again, I'll pick on a cold room in a laboratory. We'll insulate those rooms, and it kind of becomes a room inside a room because you risk condensation and water damage from that. So really, the interzonal heat transfer, there is some, but I can tell you from a design perspective and from an energy impact, it's basically, you can ignore it.
Yeah, that's super helpful, Fred. Thank you.
Yeah.
It does affect your sizing if you're sizing a system, but you're right. Not trying to be pedantic, but I think it's more of a size. Has more of a sizing impact if you put an adiabatic wall between your perimeter zone and your center zone. Then that's probably going to affect that more than the actual energy you sort of thought.
Right. So in the actual reality, it's it keeps it actually oversizes your system slightly, not hugely, but there's since that heat is not, that's because let's say you have two rooms that are kept at 72 degrees. One's a perimeter office space, one's a core office space. That office is going to be not 72. It's going to be 73 or 74 when the sun's shining on it, because the HVAC system has a deadband, and there is some heat transfer there. By preventing that heat transfer, you're essentially putting all the load on the perimeter space, and you're now sizing the system, or you're sizing that zone distribution a little larger than it needs to be. But again, at a system level, and we're not making Swiss watches here when we just even designing complex buildings, they're not that precise. So it's in the noise, and it is a huge complexity that has very little value add.
Right. That's really helpful to know, Fred. Like, this kind of just justifies our direction towards using building area types instead of space by space method for defining building geometry.
Yeah.
Dimitri, was that what you were on about though? Like, I thought Dimitri was more interested in, like, how is this like almost like a sort of automated assignment of space by area? Like, if you get a model. That was kind of
what I was getting at. Like if all your perimeter spaces are office versus the perimeter is used as a corridor, for example. If you just area weight all those space types and just kind of lump them all together, how much variance do you get on the EUI in that scenario? Because PRM, we're mostly interested in annual energy consumption. Certainly, this wouldn't help you design the systems by smearing all the spaces together. But is it a reasonable simplification to make for this simple code compliance model?
Again, you have to be careful with the area weighting, because you'll have different. It's not just the area weight. You have to area weight the lighting, the equipment, the people, the schedules, the ventilation rate, and so doing that, getting a good approximation with that from which I've done in a spreadsheet to simplify my model to see what the difference is. To do the area weighting correctly, because essentially what you're doing is kind of letting the model do the area weighting for you by parsing it out into little blocks and then having it aggregate the the loads of those and the schedules at the system level. To do it manually prior to putting it in the energy model, that probably would actually cost more time.
Right. I think it would be very difficult, particularly when you get to like ventilation. But if there's a rule set, for example, that worked all that logic out and the software could do it, what kind of difference in results would we see? And maybe you're going to get to that, Fred, during the demo.
A little bit, yeah.
I think what you'd probably want to avoid is a situation where you're sort of averaging, you know, like, oh, I've got a meeting room and I've got a massive atrium and I've got some office space, and we're just going to average the loads from all those spaces and create like a single space load profile. I don't think that's. I don't know if that's a question. It didn't seem like that was a question, Sapri, but I would avoid that sort of thing.
And again, it won't help you if you're trying to answer specific design questions.
No.
Again, it's one of those, and maybe it's a little bit experiential after having done this for more than a decade, of what simplifications I can make and which ones I can't, because I've seen those questions come up, and it's really super annoying if you've created a simplified model that you now have to throw away and create a new one that's just ever so slightly more detailed.
I just have one question about this though. These are all 4 different methods, and nobody's excluding a more detailed analysis. I guess what we're trying to decide here is what is kind of, well, for lack of a better term, the bottom or the least resolution that we can actually move forward on. So I think your comment, Fred, is valid. But I guess it depends on what questions you want to ask and what kind of model you're going to be putting together, but it still follows inside this workflow. But I guess the question is a single zone, no perimeter core kind of designation good enough to actually deal with code compliance? And have we answered that question? I think it is, but
I think we're trying to say. I think we're trying to say it's not. But I think but that's
right.
I think what you'd find is, Phyllis, is if you did say that it was okay to have unzoned, like a single zone per floor approach, then it would be quite easy to game the code to sort of like get around bad facade design.
Right.
Especially once you have like a larger floor, like floor area plate or floor plate.
And computing a perimeter core is actually not that hard geometrically inside a model. So it's just simulation time, I guess, that we're talking about for, I think it was Fred that was mentioning doing hundreds or maybe even thousands of iterations. It would reduce simulation time. But from an implementation perspective, I guess it's not that bad. So it sounds like it's a good idea.
Right. Let's move forward a little bit. We're still on the first topic, and we have 4 more topics to go before we hand it over to Fred. And to Philroy's point, I agree. It's not a big deal for simulation tools if we provide some guidance that. So maybe there is some requirement in the rule set which defines, and this is what we've done for TSPR. If the length of a facade exceeds a certain length, then you need to split it up into perimeter and core zoning. And that could be the kind of guidance the rule set includes and encourages or requires the use of perimeter and core zoning. But in either case, I think this would be a good thing for us to test when we do a validation of this rule set. And another thing which Dimitri mentioned, the automatic assignment of spaces, that's another thing we could visit. And I'll also think about that a little bit more, Dimitri, and follow up with you on that.
So Priya, there is a question on the screen that we haven't addressed at all, which is what is the acceptable variation?
Yes.
If you want to keep it moving, that's fine.
No, we should
I just
talk
know that you
about
asked that question at
briefly.
some point. I think the answer is 5, by the way.
5%.
Throw that out
Okay.
there. Just to get the conversation started. Sorry.
Right. And just to encourage people to think about it, I was thinking more along the lines of 10%. So
okay.
now that we're being really random about it.
Right.
Yeah. I think it does require some simulation to identify what the impact is going to be.
Yeah,
but
for sure.
I think 5 or 10% might be a good place to start. What do others think?
Yeah, I agree with the needing some simulation, and I was actually going to reference it in my my opening pitch for what we're doing here.
Oh, excellent. Yeah.
But there was a paper. This is totally coincidental, so I'm kind of jumping ahead here. There was a paper presented last week at BPAX from Rafaela Panizza. Didn't know her before her presentation at all, but she did that sensitivity analysis for at least a smaller building subset. It was, I think, based for Montreal or Quebec, a city in Canada. She's in Canada, but essentially went through that and did some parametrics there to show what's important and what's not, and how much variation is acceptable, because it's also going to be somewhat climate dependent.
Right.
Some locations are more facade or environmentally driven than others, so the percentage might be climate zone specific. It's adding more complexity, but or maybe group some climate zones, put 1 through 3 together, 4 to 6 together, or something like that. So it's not so bad, but they're something along those lines. I don't think you're going to find a one-size-fits-all.
This is Chris.
Yeah, go ahead.
When you guys developed the asset score, and years ago, did you do any sort of national scale modeling that would give some data sets to help understand this?
Right. So yes, Chris, that's a good point. Now that you mention it, we did look at the impact of building geometry on energy use, but we just looked at different aspect ratios and orientation. We didn't really answer this specific question on whether if you have difference in a difference. Actually, we did for variation in condition floor area or floor to floor height, floor to ceiling height, things like that. That might be a good place to also look at. I did not think of that.
Yeah, and I think the comment made a moment ago about it being climate zone.
Right.
That's what I got out of the asset score technical documentation, is that there's a lot of things that are sort of climate zone specific guidance.
Right.
And so this acceptable percentage is probably another one of those.
Okay. Perfect. We will look at that. Okay.
I got one more thought for this, Supriya. I think maybe you want to know, and this is kind of what your acceptable percentage on the overall energy use variation should be, and then use that to inform your analysis.
That's a good point.
Right? Yeah. Because I think, let's just say you had a lot of buildings that were quite narrow or small, and so the facade had a big impact for this code. Right. And you're saying there's a 10% allowed. Would you be okay with a 10% variation in energy use? Right. Because then you're basically giving all the people who know what they're doing a 10% leg up against people who don't.
Right.
So I'd say that's probably part of your study in the energy sort of analysis as well.
Yeah, good point. Yeah, coming up with the simplified rule set is not as simple. But yeah, there'll have to be those considerations. The building geometry, you're right, for a building with a high aspect ratio, geometry is going to have a bigger impact. So we'll have to keep all of that in mind when we do this analysis. Okay, I'm going to move on to the next topic. I do want to give Fred the last 30 minutes to show his tool, and then we can talk about a few more of these topics. So I'll try and end in 30 minutes. So just to talk about, getting into envelope properties. For simplified tools, again, we're now trying to identify the level of detail we need for a proposed building to define, its construction assemblies. And there are, again, going from the easiest possible approach to a more detailed approach. The easiest possible approach is the rule set would define the construction type for the different construction types with the different layers, and the users only required to specify the overall assembly thermal performance. So let's say the rule set tells us that these are the 4 different roof types, 4 different wall types, etc., that are permitted for analysis with this s-PRM approach. And the user simply tells us what the assembly U factor is. Sorry, that's the second one. The first one is the rule set, even easier than that. the rule set just defines what the wall type, roof type, etc. are, and the user only provides the U factor. So if we would, this essentially limits the envelope evaluation to a point where you're only evaluating U factor, you're not evaluating things like thermal mass or any other aspect related to the layers of construction. And the third method is the most detailed, where there is a prescribed material library and a user is selecting from that default material library list to create their construction assembly using a layer by layer approach. And those individual layers then are used to calculate the overall assembly thermal properties. So in each case, we're talking about, well, the third method requires the most effort from a user and also from a simulation tool. And for all the simplified tools that we evaluated, the third method was only supported by eQuest. We also think this would be the right way to this would be the right approach to require for s-PRM. So s-PRM could have an appendix with all the different materials and their properties, and that would be prescribed, and the user could select from that to calculate the assembly U factor for all of the different opaque assemblies.
Just Appendix A. Would that be Appendix A?
That would be Appendix, yeah, very similar. So maybe a little bit more organized for the way tools require it. So I'm thinking more along the lines of what ComNet has rather than Appendix A.
Right.
ComNet has a material library, yeah.
Supriya, this is Chris.
Yeah.
Whichever method is chosen, I would highly encourage us to not create new data elements that aren't supported in GBXML or Building Sync or some data transport methodology we're going to use for this. Try to map into those sorts of things as much as possible without creating new structures.
Right.
That then does that make sense?
And Chris, what's the motivation for something like that?
Data interoperability amongst tools.
Right. So, okay, like, yeah, we haven't thought about, we haven't thought about data interoperability from that perspective for defining this rule set. We're not really creating a tool, right? We're creating requirements which tools would implement. So if a schema doesn't have certain properties, then that schema could be expanded further to include it. GBXML might be more appropriate than Building Sync for something like this, but I'm not sure how much we should be limited by the GBXML capabilities for defining rule set requirements. Just think about Appendix G, Chris, like, I don't know how much of an energy model which has been developed to represent Appendix G requirements can be translated by GBXML, but that doesn't mean that Appendix G shouldn't be adding more requirements, right?
I'm just suggesting if a barrier to adoption and scale will be things like data interoperability. So just keep that in mind, that's all.
Okay.
I'm just suggesting that if we do create new data structures, and we'll make it more difficult to actually deploy.
That's a good point, yeah.
And this is about scale and low cost and adopting things that exist already as much as possible. It takes longer for things to catch up to change.
That's a good point, yeah. Okay, we will evaluate both of those data models to see where we land with all of our requirements.
So Priya, I think that this proposed approach is really good. Just wanted to say,
Seriously, Andrew, for the first time we've gotten that from you.
Wow. Yeah. No, I think it's the right way, and I think that well, like if we had our time again in Sapphire, like we've often worked about how to refactor the code to sort of like do something like this. But this is definitely the best way to think about it, whether it needs to be as complex as what you see there. But certainly the practitioners who are sort of making these decisions are not thinking things in terms of assembly U values. They're thinking about in terms of what the materials that they're going to be using are in the model. And so you do make it more accessible somehow to architects by actually providing something that could be read off a detailed drawing rather than something that they have to go and work out separately.
Got it. Yeah.
So I think it's a good approach.
Yeah. So
we've used something like similar to this inside our tools that we had, and it's good to have that kind of detail, obviously for understanding what's inside the constructions, but also for costing as well. Being able to actually take this and show the architect not only what this R30 wall is, but how much it costs them to actually put into that building. And I think that's going to be critical as we look at some of these and start looking at costing more in depth.
Fred, I'd make 2 points. One is it since we're limiting the use of exceptional calculations, it means the tools need to be able to do this internally. I know a lot of projects use something like Therm to get a more detailed wall analysis and then carry that through with an assembly U value into their models. Sometimes we build them up, sometimes we don't. I guess the process of creating this thing, it's another thing that takes time. And I guess the overall question we should be asking for every single thing is, how much impact does it have of using this built-up mass versus just having a fixed U value? Which since you have eQuest up on the screen, it handles both. And so what is the difference in results between the two?
Right, and that's a good point, Fred. And my guess is it's not going to be that significant.
I would agree.
Aside from the cases where there's thermal mass, but again, even when there is thermal mass, I'm not sure how significant it'll be.
Right. Thermal mass has an impact on peaks, but on total energy, not a whole lot. Unless you go to a lot of thermal mass and you're literally shifting the peak hours and can design your HVAC system to leverage that. But since we're doing simplified things here, I'm assuming that's not how people are going to be using this.
Yeah.
Well, what does this really mean, though, from an implementation perspective? I'm sorry if I cut someone off. I'm so sorry. Just in terms of like Fred's comment, because you're going to say in the rule set that people need to describe what the assembly is, right? And then the associated U value rather than just having a U value. I mean, then it would be up to the software to sort of like, to the user of the software or the software itself to provide different ways for someone to be able to do that. You'd theoretically still have a U value input. You could have a U value input in the software and then have someone calculate it somewhere else. But you're just saying that they have to show that assembly, right, as part of the submittal?
Right. So from the rule set implementation, this basically means that the rule set would require construction assemblies to be defined using a layer by layer approach. So and the layer material properties would be prescribed by the rule set. So again, from a software perspective, whether a software allows a user to select those layers or just uses the layers on the back end and a user defines the U factor, that's from a software implementation perspective. The rule set will simply require the use of layer by layer approach.
Okay.
Is there any consideration on thermal bridging here? I know we have metal frame, well, the frame thermal bridging is probably taken into account, but also other pieces of like parapets, balconies, things like that. I know I'm getting into the details here, but one of the things in Canada is we are really looking at those thermal bridging pieces, and they've come up as a big item for parts of our climate. And I was just wondering if is that an issue down in the States, thermal bridging and effective R values?
Right.
In
so
our,
this is,
Sorry, in our northern climates, yes, this is a big deal. It's a good point. I mean, we deal with this on projects all the time where somebody has come up with a curtain wall that they claim is an R15, but in reality it's an R4 because of the three-dimensional heat transfer found in curtain walls. And so it's a really valid point of, if somebody builds something up, but it's not accounting for thermal bridging, they can have something that's 3 times worse than what they're seeing, and the tool very well might mislead them. Because, you know.
Yeah, thermal bridging hasn't made its way to 90.1 yet. The envelope subcommittee has been working on getting those requirements into the standard. So before we actually figure out a way to get it into s-PRM, we'll wait for it to make its way into the detailed PRM. But yeah, Fred is right. Whatever analysis has been done by the envelope subcommittee, they've shown this significant impact on energy use for these different scenarios. Gail, were you trying to ask a question earlier?
Yeah, it seems like the rule set allowing options would make sense in this case, where you could get more detailed if you want to in geothermal mass, or you know, the simplified energy modeling tool could choose not to have that as an offering. And so it seems like allowing options here and not limiting it to one of the 3 cases that's shown might make the most sense for this application.
Okay, that's helpful. So based on what all of you have said, I think the first thing for us is to identify the impact of this simplification. If a user is not getting to choose the different layers, or if we're just modeling a simple U factor and there is no, we're not evaluating thermal mass, then what's the impact on energy use? And if the impact is minimal, maybe the rule set can allow options and not require the detailed method for the detailed layer by layer approach.
Supriya?
Yeah.
I mean, I think if it's being used for code compliance, you have to know whether or not it's a mass construction, because most of the codes have different, you know, baseline requirements for that. So I don't see how you get away from that.
Okay.
And the issue of whether or not you just use a U factor and standard assemblies, you're not going to, if you, you have to look at assemblies that are different from those standard assemblies if you want to answer that question about whether or not you're going to get different energy use. You can't just try and replicate the same assembly and use a simplified assumptions for it.
Am I understanding that right? I mean, I thought, like most modeling engines, you know, regardless of how you built up the input of U value for this object, just uses the assembly U value for the object when actually modeling it. So like, it doesn't matter the path you take, whether you build something up or just enter a value, you're still just, as long as you build it up to the same value, you're going to get the same answer. Again, apart from not having mass involved, if we're talking about just resisted to heat transfer, then I'm not sure it matters how you get there from a pure modeling result perspective. Is that true? That's my understanding.
We still have observed results in terms of what's submitted in terms of something that's modeled using a delayed assembly in accordance with the Appendix G rules, or something that's modeled using just a simple U factor.
Is that, I always thought that was because of the thermal mass, but maybe I'm wrong in there.
I mean, it's tied to, you know, the amount of mass, but even for you know, light frame assembly, there's still a little bit of a delay there.
Yeah, I mean, like I think that theoretically, what the engine's doing is that, and if you're just assigning a U value, then you don't have any thermal mass. But if you build it up, then it's going to use the component by component thermal mass to get thermal mass, and then use that in the model to do delayed time. So I guess
really. Go ahead. Sorry.
I'm not exactly sure what my point is. I think it's more like, if you're going to do some sensitivity around, you know, the difference, then you should be just careful to know that what I think you're really doing is if you're looking at the impact of thermal mass and not the impact of like building up a bunch of U values, component U values to get an assembly U value. I think
Yeah,
the
absolutely.
real question in the assembly U value question is what you guys brought up a second ago, which is, are you actually calculating that correctly? And I don't think anybody is, because of all the thermal bridging and 3D effects that I brought up.
But it is also just the U factor, because even if you're just using, you're not including mass. If you use those default constructions, I mean, typically what a common approach is to say, okay, you've got a wood frame wall or a mass frame wall. What's the R value of the insulation in the cavity? And that works out fine if you happen to have a wall that actually matches exactly the assemblies that are in, Appendix A of 90.1, and you end up with the same U factor. But if you've got different stud spacing, or if you've got different exterior sheathing, interior sheathing, face break and air gaps and all those things that are slightly different from those default assemblies, then you end up with a different U value. So that's kind of one of the important points that I think we were hoping to avoid with a layer by layer construction that maybe doesn't add that much work to it. So there's really two questions. The mass is a second question.
Like putting the thought into building it up layer by layer, so you're getting as close to accurate as possible of an assembly U value.
Yeah. And unlike the different methods, this is not a great deal of complexity. It's not adding a great deal of complexity to the modeling approach, which is why this was one place we thought we could go ahead with additional accuracy. Okay. Yeah. Any more comments?
Sorry, I know this is going to sound really unfair, but I'd just be careful not to optimize based on what's hard to implement in the analysis, and like focus on the questions you're trying to answer. And I think this is a great thing to do if you want architects to be more aware of like how the materiality affects the design. But I would sort of be cautious about just assuming that certain things like aren't that hard to implement or whatever, or using that as a driver. I know I'm jumping on what you just said a bit too harshly, but I just an encouraging.
No, that's a good point, because we might have different understandings of what is difficult, what's easy, and it shouldn't be based on that. Yeah. Okay. So we've gotten like different feedback, like everybody has a different way of thinking about this. To one point, Gail's recommendation is to allow different approaches, not require a certain approach. And Andrew, you recommended going with this approach because architects that way are aware of what's going in the building. It's also useful for costing. I guess we'll have to think about this a little bit more. I'm a little hesitant to say which approach or which suggestion we should adopt in this case. And I guess a little bit of it would also be determined by the sensitivity runs we do. That might help us make our mind on decide on which approach to adopt for assemblies. But I will move on to the next thing. This is going to be a long one, but it is important. And then we also have lighting. Let's quickly talk about fenestration and daylighting. This is something we've struggled with internally quite a bit, and it would help to get everyone's feedback on this topic. So when a user defines fenestration area, the one simple approach is like allow windows to be combined into a single window centered on each facade. Similarly, skylights, allow skylights to be combined into a single skylight centered on the roof. This would significantly simplify, or the parallel to this is allow input through a window to wall ratio or skylight to roof ratio. So this would significantly simplify the way fenestration is defined for a building. However, this also affects savings through daylighting control. So just jumping into daylighting for a second, most of the tools we looked at, simplified modeling tools, do evaluate daylighting So I wanted to get a better understanding of how are these tools, or what do you think your thoughts are on the level of detail for defining fenestration, and also how are you then evaluating daylighting based on that?
I guess I'll jump in. Bunch of thoughts. We've talked about, like daylighting is required in 90.1 these days, but LPD values keep getting lower and lower with
Right.
better lights, and so the value of lighting controls is diminishing every
Right.
year.
Right.
And so again, having that conversation around what impacts the outcome of the model, so I guess you'd have to again have some guidance here for the modelers to say, okay, if you have a building that has a lot of glass, or lighting is a significant factor in your total energy use, and you want to account for it or not. For a lot of the buildings that we design, we put daylighting systems in all of them because it's a good idea, but it really doesn't move the needle energy-wise.
I see. Yeah.
So it would be one of the ones I'd be willing just to drop entirely, say, okay, this is just ignore daylighting entirely. I'm sure that there's a few folks who'd be cranky with me for saying that. And again, it'll be, again, going back to Andrew's point of like, say you're doing you have a building that's a big atrium, there's lots of daylight coming in, and there's a lot of area lighting. You might not want to ignore it for that. But if you have a deep plan office building where daylighting only hits, 5% of the floor plate,
Right.
it's not going to show up.
I think sorry, I'll just jump in and agree. I think for similar reasons, well, I'm completely fine with one single window and one single skylight. From it will get your thermal load right.
Correct.
And then now we're talking about, and probably your thermal heat, like your direct normal radiation from the sun. Sorry, it'll get you conductive and solar loads right. And then to do daylighting really well, you need a pretty sophisticated radiant style engine, and you need to, put a lot of thought into the geometry and partitions and all this other stuff that I think is well beyond the simplified approach. Yeah. And I certainly agree with surface colors. Yep. Yeah. Mounting heights, all kinds of stuff. And then, yeah, I agree with Fred. The savings is diminishing, and there's because of that, and because I think there's pretty decent studies out there we could reference around what typical daylight savings is. You could just do this as a % savings factor on the lighting, like TRMs. I've been on several committees that try to just get like control savings factor for occupancy and for photo control and for occupancy and photo control and for desk tuning, and it could just be a lookup table that references the LB and Almeida study, or what it says. If you have these controls, then basically reduce your LPD by 5% or something.
Yeah, because it may be easier.
What if
it may be easier if you're. I agree with that, because like if you don't have the position of the windows is highly important in determining daylight and things like that. So if you do know that, like for example, maybe someone has run a full daylight model, they know that they have 55% SDA or something like that, they could actually figure out from that the factor that is most equivalent from a daylighting perspective in terms of reducing their overall lighting load. And so that, I think that's a pretty legit way of doing it that doesn't require people to do a full daylight analysis.
I didn't hear one word you said. 50% what?
I was saying that if it's like 55% spatial daylight autonomy, and you run like a whole daylight simulation, you could just use a factor in the interval model. Would probably be
I think
better.
Yeah, I think simplifying it along those lines
is similar to the other approach where we have these default factors, and then
yeah, you override a default with a narrative that says, I did this model, it gives me this, and that's your, I think that's The exact
What if we asked? What if we asked the area that was in daylit zone is defined by 90.1, and then we apply some sort of savings factor to that
Nice.
area?
Yeah.
I like
It's
that
the
approach.
second time
I
we've
would
done
recommend
that.
that.
Yeah. Go ahead,
That the
Pierre.
factor be, I would recommend that the factor be tied to the equivalent full load hours of operation that are during, or the proportion of operating hours that are during daylight periods. With the simplified energy model, that should be pretty easy. You could just do it by building type, but you know, making sure that the operating hours are somewhat accounted for in terms of that factor.
Perfect. Okay.
Most of that will be embedded in like the percent savings that literature would point to, I think.
Would this may seem like a silly question, I'm not even sure the answer, but would this actually impact natural ventilation if some of the models are actually tied to where those windows are? Or maybe we're not even entertaining that as a design parameter.
Yeah, we're not, Phil Roy, natural ventilation is something that we're not going to deal with. We get to choose what we want to deal with and not.
Okay, that's fine.
But yeah,
just to build on Phil Roy's point real quick, just as a note, we shouldn't tell people don't have operable windows. Just you can't take credit for it.
Yeah.
Like we don't want to tell people it's a bad idea because it's not. It's a good idea, but yeah, taking credit for it won't work in s-PRM.
Okay.
Supriya, I was just going to suggest like one fairly simple way to do this is to, if you have standard schedules for internal loads, and also if you do perimeter core or you have perimeter loads and core zones, then you can have a schedule where there's a natural reduction of lighting power, like by a fixed amount, whether it's a percentage or something, across certain time steps. And you could probably embed it into the schedules, so that it's sort of like it's oh yes, you've got a daylight control system, then you can use this different schedule, right? And then that like just what it means is it's really easy to check. They're like, you've applied this schedule, so you have to have a daylight control thing for that zone that you use that schedule in. And you don't really need to worry about, I would have thought, especially if you've got perimeter zones defined already, you probably don't really need to worry too much about like whether there's how much window there is in that space. I mean, yes, it's possible people will have designs where they don't have that much glass, but I think for a simplified model, you can probably assume that a perimeter zone will be well enough lit to sort of, you know, go down that path.
Yeah, that's the old.
And then also, well, I was going to say as well, and then you're also capturing it in the space loads. So you do the calculation within the energy model of the reduced load, and it captures that, which sometimes is a good thing and sometimes is not a good thing.
Right.
That's it. Yeah, sorry.
Yeah, and actually that was the accepted way to actually do daylighting in E4 or Energy Pro years ago. So that's what was used as an equivalent in the code, at least here in Canada.
Okay, that is super helpful. Excellent. Any more thoughts or discussion on daylighting? So based on what just to summarize what we discussed, all of you are recommending having some simplified way to analyze savings to daylighting, either have some kind of a percentage reduction or modified set of schedules, which reduce the, which account for savings during operation, the building, when the building is actually operated and daylight is available. And generally all of you feel that having a single window, like a simplified way of modeling fenestration is okay because thermal load is accounted for and daylighting savings would be accounted for through a different approach. We would not explicitly analyze daylighting.
Just to be clear though, this doesn't preclude people from doing advanced analysis if they want to inside this area, like actually having a physical daylight sensor, well, not a physical, but a virtual daylight sensor in the model that actually detects things, right?
Right.
Okay.
They would then go through the detailed Appendix G approach. So then this, yeah, nothing's precluding them from going through a detailed approach.
Yeah.
Yeah. Okay, any more thoughts before we move on? Okay, I did have a lot to discuss on lighting, but Fred, I'm gonna hand it over to you now, and we'll probably cover lighting at a different call.
Sounds great. Thank you. I don't know if you have to pass a ball or something, but it's going to be you on sharing a screen.
Okay,
And
so you and just try sharing. I think you should be able to.
okay, and while he's getting that I'll just give a quick little intro. I'll try to keep it quick. Hopefully no one falls asleep. Just give you a little bit of background. So for about the last 4 or 5 years, AEI has been refining and revisiting every aspect of our entire energy modeling workflow. It became pretty darn cumbersome. That's a long story for another day. And we actually found that the simplest approach worked around Energy Plus. And this is native Energy Plus, and you might say, how do E plus and simple go into the same sentence? And we'll describe that. This meeting's timely because Iwan presented on this demo last week at BPEX. There's a paper we co-authored, so there's more details there. But AEI is known for its complex building projects and equally complex energy models that go with them. But not every project requires that complexity, and we definitely do design buildings that aren't all like that. Not every building is net zero, as much as we wish it were, and so on. So we definitely have projects with simple HVAC systems and package heating and cooling, and we really wanted to have one modeling workflow that worked under all conditions, under all our needs, which are pretty broad. And another big factor of this is some of our simpler projects don't necessarily have fees to support a full-blown detailed analysis. So we needed something that was fast, but the same, if you want to do a net zero building or you want to do a simple building, it should be done the same way. And really why we're here is to answer design and analysis questions. But we don't know what those, that we talked about here during the discussion, we don't know what those questions are going to be. They change per project, they change per team. So flexibility is, again, one of our big drivers. And one of the first things we had to do when we ventured down this path 4 or 5 years ago was really deciding what's important and what isn't important. And I mentioned the reference to Rafaela Penita's BPEX presentation last week. She did a nice job on showing, and the results matched what we were seeing, what's important and what isn't. So I'd encourage you all to check that out. But really, challenges for delivering this quickly and efficiently. And this will sound like a repeat from the last hour and a half. Creating geometry, developing complex HVAC systems, and then before we had one tool that did everything, was having multiple tools and parsing data back and forth and exceptional calculations, re-entering information from simple tools into detailed tools. And so as we started down this path, we're mechanical engineers for the most part. So we started on HVAC systems. And one of the great things about Energy Plus is the code is pretty portable. And so if you figure out how the system works in one model, you can apply that to other models. And if you aggregate all that knowledge into a spreadsheet, you can generate those models with functional HVAC systems. And so we very much followed the 80-20 rule. You'll see some of that here. For example, we have chill beams on, or at least get considered on the vast majority of our projects. So that is just automatically generated. So there's really no limitation there. The other part, and this is probably a little most relevant to this, or the other parts are most relevant to this group, is preliminary models. They're they're fast. We've had a lot of those presentations. But, and I mean this in a nice way, they're kind of throwaway models because you can't necessarily use them for code or rating system compliance. You can't model certain complex systems because they're black boxes. They do what they do, and they do that well, but they don't do everything. And again, that really restricted us on flexibility wise. So again, we do some odd systems for some of our projects. And then also, if you switch tools in the middle of a project, you do run the risk of getting different results, and we've definitely had that happen on projects. So it's not something that a design team really wants to deal with. And the last real challenge is the time-consuming nature of creating geometry, and that's what we're going to tackle first here. Is especially early in projects, the geometry is always changing, so we need to have a solution that was super fast. But we also want a solution that can evolve, and it's nimble today, but as the design progresses, we can keep one model here, and that's actually what the case study in the paper Iwan and I presented last week talks about, that of taking this simplified approach and developing it into a big, comprehensive, detailed energy model that would, most people would be afraid of doing. So I'm going to hand it off to Iwan to walk you through the generating a model live here. We're going to generate an Energy Plus model. So take it away, Iwan.
All right, sounds good. Thanks, Fred. Can you see the screen? Can you guys see the screen?
Yes.
Okay, great. So for those of you who don't know me, my name is Yuan Jia. I work at FA Engineers. And before that, I graduated from Georgia Tech, the High Performance Building Program, being AEI for like last 4 years. Like Fred mentioned, this is really a collaborative effort for the past 4 years. Been enjoying working on this project. So from the beginning, I guess, a quick overview of the two. We have the info tab where you can define like high-level building project information, design day information, and some like weather locations. And the reads tab allows you to define either a virtual read, like simplified read structure, or if you have more complex, like tariff-based read structure. And the mix tab allows you to define this like exterior lighting, service hot water heating, and some other planned loop loads, like process loads. Your steam loads, for example, on your hot water loop. So beginning from a project, like before that I should mention, this is the tool called IDF Exporter. It's really the energy modeling platform we have been using for most of our energy modeling projects at AEI, in Madison office especially. So starting from the project, after we define all the like high-level project information, we usually started to define space types. For example, like lighting power density, EPD, equipment power density, occupancy, and ventilation, set points, etc. And also schedules, right, based on like the space types. And after that, there are two ways currently to import geometries into this workflow. First is a conventional approach, which we will trace the detailed geometry in SketchUp using the OpenStudio plugin. And second, which is more in line with today's topic, which is the simplified geometry workflow, which I probably spend more time here because since this is a topic today. Basically, we will define all the building geometry as shoebox models, and each row here defines individual zone, and you can define space type, by the way, is linked to the space type database, right? You can select your space type here from the space type tag you created. And building level and the building zone name is automatically generated based on your level and space types. And there's a zone multiplier. We can like duplicate or zones to really reduce the file size if you have a lot of duplicate zones. And we basically enter the zone height, zone length, and zone depths. We call it east to west and north to south, and zone heights and ceiling heights, and whether there's a interior roof or not, and the ground contact boundary conditions is whether it's adiabatic, slab on grade, or basement. And we can define, currently we can define true perimeter normal such that we can define a corner zone. For example, the first zone here, corridor, is has a north-facing external zone, external surface, and also a east-facing external surface. And then the window-to-wall ratio will apply to the all external surfaces based on whatever percentage you entered here. And we can also define a shading based on the shading depths. And furthermore, we can create or using ASHRAE default construction templates. So for example, here, these templates values are linked to a construction library within this Excel2. If you have a different like customized template construction, you can just create your construction templates and then enter whatever wall U values, roof U values, and then assign the construction templates to be your construction for this zone. And after that, we can define all the information will be show up here once you click import simplified geometry. For example, like if I want to update this geometry here to be 60. So we see that the total floor area is updated here. And once I update the geometry, and that zone area got updated. And then next, we started to editing the systems and planned side, like HVAC systems.
Yeah. Before you go there, you can go back to the zone and notice that we have building or spaces that would be served by chilled beams, and whether they have the photocell for daylighting or any sort of zone level systems also get assigned here as if they are applicable or not.
Right. So also you can assign the loop loads, your water loop to serving your terminal devices. Here in this tab, you can define your multi-zone systems, and whether there's a single zone system. You can define active chill beams here as well. So for this project, we have for this example, we have two multi-zone system and also a fan coil system. And next, we go to the assign. These space zones are assigned under the HU1, and this has, for now, this is happened manually by looking at the HU zoning diagram. And fan coil units. Next step really is define your plan side systems, your plan loop, water loop, loop supply temperature, loop delta T, and your plant equipment, right? Whether it's a district heating, cooling, or boiler, chillers, or HRCs. heat recovery chillers are can be modeled directly from this tool as well. Cooling towers and pumps. And really, this is all the information we need to construct a complete building energy model. And after doing that, I'll just export this model, this IDF energy plus model to a temporary folder. I'll just put it here for now. And I just an example, I'll show you like what are the zones, what geometry looks like after we define using a simplified geometry interface. So these are basic all the zones we just created. You see from the boundary condition, there are some zones has external surfaces with windows, and this is like ground contact surface. And for the second floor, there are no contact, so it's adiabatic.
This goes to that point of us talking about interzonal heat transfer before. So since we found that that is not a huge factor, all these zones essentially can be standalone little models because they're not at the zone level. They're not interacting with one, or they are in reality, but the interaction is so small. Now we've created this whole. This is a whole building energy model broken into tiny little pieces, and the simplifications that we've made. Again, we've generated geometry from a spreadsheet. The simplifications that we've made don't cost a lot in terms of accuracy. But now that whole model this thing's ready to run with all the systems, and again, those are AI defaults that we showed you. But if there's s-PRM defaults you put in their place, it's just a different number in that workflow. But we've now taken that piece out of it. So if you want to keep going, anyone?
Yeah, I'll just add to that, Fred. The other benefit we'll find out using this, by assuming the adiabatic interzonal heat transfer, a benefit of doing that is we can actually have the freedom to enlarge whatever zones or updates whatever zones while design progresses. For example, here, if we at certain point of the project we find the mechanical room got updated. Got enlarged. We can simply just type like 50 here, and then just simply update the model, and everything else still works because there's really no interactions with other zones. There's no adjacency issues with other zones. By doing that, we can really reduce the amount of rework by updating your geometries. And once I've done that, I guess I'll just re-export to the model temporary folder and launch your IDF exporter. So I think this is 150, yes. And select and hit run. And it should be running pretty quick. It's really a small model here.
So the beauty of this system is, say you do have a simple building, you're done. Say you don't have a simple building, and again, you don't know what you're going to get. You can take this, and again, there's some of the some ability to make changes within the spreadsheet tool. Again, following that 80-20 rule, a lot of our buildings need chill beams, so that is a standard simple input for us. It might not be for somebody else, but that's fine. Mm-hmm. And we just, because it's one we do on just like a heat recovery chiller, also and used in most of our buildings, at least tested in most of our buildings. So we standardize around it and created a workflow that works every single time. But again, weird stuff happens. Something changes. I've had buildings double in size. Whatever. And they add new systems and complexities. You still have a fully functioning IDF that you can now run with and do the full detailed model if you wanted to. And so the paper that Ewan and I presented last week was actually for a 500,000 square foot hospital, which we did in a simplified model initially, because there were things changing all the time, as is very normal for what would by most definitions be a very complex building. But we did a simplified modeling method to generate that building. We then did exit this the environment a little bit to prototype some really unique mechanical systems that were special for that building. And then as the design progressed and the floor plans settled down a little bit, we did go through the process of creating the full detailed geometry in OpenStudio with all the adjacencies and whatnot. But we're able to take all this information that's in here and apply it to just a new geometry.
Mm-hmm.
So nothing was lost. All the relationships, the air change rates, the temperature set points, the schedules, all of that is still the same. So we have no differences between, or we've minimized the differences between our simplified and our detailed model. And again, depending on what's in the the s-PRM, it doesn't necessarily will not necessarily need you to go further, but again, the availability exists here. But it just shows that you don't if you predefine parameters, you don't necessarily need to limit what can be modeled as long as you're defining the defaults comprehensively. So multi-zone system, no big deal. Chiller plants, no big deal. You just have to, again, say what are those values? What should those values be? And again, like we've been doing with the other things, if you deviate from them, it should get flagged and you have to justify it. But yeah, all this is doing is just aggregating, not to belittle what we did here, but it's aggregating a whole bunch of information and developing standards. Again, it's an AEI developed standard for what we were doing time and time again for our energy models, and we just essentially aggregated all our lessons learned to one tool that now does, it's a lot like an eQuest wizard, but goes a lot further, and there's not that painful limitation in eQuest where you can't go from simplified to detailed mode, or it's a very abrupt change. Whereas if we want to be detailed on one air handling unit and the rest is simplified, go nuts.
So in that case, Fred, you could just take the IDF and work in Energy Plus to get to the more detail, right?
Yeah, and let's say you've done that. You've created your simplified model. You take the IDF. You come up with you develop some crazy HVAC system, and you get it working, and that's all wonderful. And then the owner decides, you know what, I don't want it. It's not it's too complicated for me, or it's too expensive, or whatever reason. It doesn't matter. You still have your simplified model, and you should just go back to a single duct VAV system, a system 7 as found in 90.1. Then you're still good. And so really, this is like I said, the culmination of 4 or 5 years of effort to be nimble and allow us to have level of detail on demand. And again, simplification really, it can mean whatever you want it to mean. In that, as long as you're putting in enough restrictions, again, chill beam can be a simple system as long as we know enough to define it and don't let people change it.
This is really good, Fred. It's a good point that you have from going from a simplified model to a detailed model. And a lot of people, especially in policy, don't understand that jump. We have a simplified tool for buildings here in Canada that's used a lot. And the problem is those are set usually very early on by designers, and sometimes the engineers aren't even involved in that. And then they take that simplified model and give it to them, and they say, I can't do anything with this. And at one point, they sized some of the systems completely wrong using that simplified model, and there's no connect between that. I think this hits the nail on the head on like having some continuous flow between early design, eventually getting to the final detailed design.
Yeah, and the other thing, again, for efficiency, because for those of us as practicing engineers, our schedules keep getting shorter and shorter. You could, if you did need a detailed model, you could have one person creating the model here and another person creating geometry in parallel, and then merge them. Which, when we get a rush order, that is what we do. It isn't necessarily cheaper in terms of hours, because there's coordination that needed to happen. But in chronological timeline, it is less. So again, that flexibility, and all of this is born out of, you know, decades of experience of, well, what do our projects need, and what do we need to be able to do to react. And you know, again, it happens to be in a spreadsheet because that's what's easy to do for us engineers. We're not software developers, but it's functional. You know, if we decided, you know what, every building needs to have, I don't know, pick a system, you know, phase change materials. Every single building needs to have, you know, because we keep getting more and more requests for it. Not that that happens in reality, but let's just say we did, and we wanted to put phase change materials in every single, be able to put them in every single perimeter zone. And it's adding a column. It's not just a snap of fingers. You have to prototype the system, make sure you get a robust setup for that, because Energy Plus has interactions with each other, so you can break things. But once we know how it works, we integrate it in here, and then every single project going forward has access to it, whether it needs it or not. And if it doesn't need it, just leave it marked as blank or no, and you don't have it, and you're not bogging down your model. So like, you know, here, photocell in zone, we don't have any daylight in this model, fine. You want to add daylight, change it to yes. You know, again, it's giving the flexibility, and yeah.
So, sorry, the last point I'm trying to make here is the other way to view this interface is you can consider this as an engine modeling data model. So basically containing all the maybe high-level information in energy models. If you are interested in this path, there's another BPAC paper published by our colleague Eric Niemeyer, was touching base on this topic, basically using this tool as a data interface to a data model.
Right. Yuan and Fred, there are a couple of comments from people who need to drop off that if you could share both of those papers, you could just simply reply to that group email with those two papers.
Okay.
Yeah.
Yep. Sure. Can definitely do that.
Okay. And this is pretty excellent, Fred. It's good to see this interface, and especially all the research that has gone behind the approach for defining the geometry and all the parameters.
And I think the thing I like about it the best is then as people become subject matter experts in whatever, and they, you know, have the time and effort to put into making sure a system works properly for their building, that knowledge can be brought back into the tool, and then everyone benefits from it.
Right.
Because there's no way to know everything there is to know about energy modeling. It's just blanket statement.
No time to do everything you know.
Right.
So
let's leverage each other's abilities.
Right. Okay. We are at time, so we'll stop now. Fred and Yuan, thank you very much for this demo, and also all the information that you've shared with us. This is definitely going to help us with this rule set project. Yeah. Does anybody have any questions for Fred? We are short on time, but I guess it would be best if we just continue this discussion on email. And if there's more that we want to talk about, maybe Fred, we can have another discussion on this topic at our next call. Yeah. Yep. So just to wrap up, our next meeting will be early December. We haven't really discussed lighting yet. We only talked about daylighting control. So we'll talk about lighting, and we'll talk about HVAC. And at that time, we'll also have a draft rule set. Well, it would have been good to discuss lighting before that. So we'll see. I'll probably, if there's more to discuss on lighting and HVAC, I'll send out an email. We might request another meeting sometime in November, but we'll figure that out. And after that, we'll also ask folks to who are interested in reviewing the rule set to kind of volunteer, and that should be sometime in December. So in fact, are there any folks who know for certain that they would like to review the rule set? Then I know a lot of people have dropped out, but if you're willing to do that, then I can kind of connect with you sooner and start sending you portions as we write them.
This is Fred. Feel free to send me some.
Fred,
Yeah,
I was going to quote you pretty hard anyway, so I'll scoot you off it.
I kind of figured, so might as well get it out of the way.
Yeah, perfect. And Shauna messaged that she would like to. Yeah, go ahead.
Yeah, me too.
And that's Phil Roy?
Yeah.
Okay, and Alex Novi from Energy Trust. Excellent. Yeah, it's even if there are parts of it that the entire rule set feels like a lot of work, I might still just reach out to you for your input on specific sections, just based on what you've been contributing throughout. So even that would be really helpful. So we'll stop now. I don't want to take up more of your time, but thanks everyone. This is really helpful for our project and a very interesting discussion as well.
Thanks, Supriya. See
Thank
everyone.
you.
Yeah.
Thanks,
Thank
Fred.
you. It's been very interesting.
Bye.
Thank you.
Bye.
Bye.